the derivative, which is what we did in the first video. And today we're going to be looking at graphs. We're going to graph f from the graph of f prime. Remember, f prime is just slopes. And graph f prime from the graph of f. And graph the derivative of a function given numerically with data. So, first couple of things I want to remind you guys of is some of the notations that are being used. There are many ways to denote the derivative of a function y equals f of x. Besides f prime of x, the most common notations are y prime. That's how we read it. Nice and brief, but does not name the independent variable. dy dx, or the derivative of y with respect to x. Names both variables and uses d for derivative. So this would be the derivative of y with respect to x. df dx, or the derivative of f with respect to x, emphasize the function name. And then the last one, d dx of f of x, or the derivative of f at x, emphasizes that differentiation is an operation performed on f. Now, this one you'll see especially in chapter 4. You'll see a lot of that in chapter 4. This one you won't see very often at all, but the others, very much so. Usually it's in instructions. The dy dx will be an instruction. Instead of saying find the derivative, it'll say find dy dx. And this is a very common one, right along with f prime. So let's talk about graphs, the relationships between the graphs of f and f prime. Because we can think of a derivative at a point in graphical terms as a slope, we can get a good idea of what the graph of the function f prime looks like by estimating the slopes at various points along the graph. We estimate the slope of the graph of f in y units per x unit at frequent intervals. We then plot the estimates in a coordinate plane with the horizontal axes in x units and the vertical axes in slope units. Slope, because derivative is a slope. So example on this one. So on this particular problem here, they want you to graph the derivative of the function whose graph is shown. Discuss the behavior of f in terms of the signs and values of f prime. So on this particular one, unfortunately on your paper it's already done, but they did give us slopes along the different values. We have at point A, from point A to point B per se, not quite, but they're giving us that there's a slope of 4 here. So what we do, now remember your x values and then your slope. So at A, I identifying this right here is going to be a slope of 4. So 1, 2, 3, 4. And this would be listed as A prime. At B, they tell you it's a slope of 1. And we can come just bring this down and identify where that is. I'm going to actually use a line. A line. That way I can identify where this guy is at. If I bring a line down from here, we can see that it's about 1.5. About. So about 1.5, my slope here is 1. So we put a point here and label it B prime, and so on and so forth. At C, they're saying it's 0. If you're not sure of the point there, you can always do that. Looks very good to 2. So 2, 0 is C prime. And then we continue on at D. D value is at 3. And my slope is -1. So 1, 2, 3. Down here is D prime. And we're going to come over all the way over here to E, which is at 5. So 1, 2, 3, 4, 5. Also -1. So E prime. And then F, they're telling us the slope of 0. And it looks at it's at 6. 1, 2, 3, 4, 5, 6. And here's F prime. Now, one thing I want to point out to you is the fact that this guy does not come down and then come over and then go up. Because nowhere in here between these two do we have a slope D and E. Nowhere in between here do we have a slope of 0. However, we do get to do an assumption that there's a slope, I'm sorry, not 0, -1, continued to be -1. Somewhere along here, we get to assume that the slope gets a little bit, it levels off kind of thing. This is what's called a turning point. This is concave down, and it comes along and it goes concave up. Anyways, it's a turning point down here. So we're just going to add an extra point down here. And then you just graph your curve. Now, I'm going to state the fact that I can never graph on these really well, but I'm going to try, and I'm going to use a fatter pen, see if that helps any. And I just come down, try to hit my points. And come back up. Okay. And here's a point they're wanting to make on this one here, is I want to show that from A to B and even to C, I have a positive slope. Well, on your derivative graph, that just shows it above the x-axis, because up here your y value, remember, this is not y, this is slope. So this is positive slopes, and down here are negative slopes. And then notice that C, after C, it starts going down, and we get a slope of -1, -1, until it gets to 0 again. Here it is. From C to D is negative, over here is negative, negative until we get to F. And after F, the slope starts to go up again, we get a positive slope. This is one of the things that's very difficult for students to do, and I understand, I just need you to get your mind wrapped around it, is that when you're looking at F prime, you can't look at it the same way that you would look at a regular function graph. This is a slope graph. This is graphing all of the different slopes that that function has. Okay, let's look at another one. Given the graph of the function f below, sketch a graph of the derivative. So one of the first things you're going to look for is where the slope equals 0. And the slope equals 0 is going to have a horizontal, because, right, horizontal lines have a slope of 0. Which means right here at -2, I'm going to have a slope of 0. I'll make that nice and big so you can see it. And over here at -1, I have a slope at 0. And this is what my graph is going to look like. And then before this graph, I have positive, positive, positive slopes. And at 0, it starts going down. It's going to be negative, 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 until it gets down here, and then it starts going positive again. So anyways, when it crosses the x-axis here and here, it's going to go positive, negative, because we have negative slopes between our two zeros. We have nothing but negative slopes. So between here and here, it'll be down here. What I want to ask is, about where on this side of the curve is a halfway point? This is quite symmetric. I mean, it's one of those that we'd have to move it a little bit to have it symmetric to the y-axis. So where is it symmetric to? Well, keep in mind that we can count 1, 2, 3, and 3 divided by 2. But it's not just 3, because this is the negative side and this is the positive side. Okay, so we can't do it that way. How about -2 plus 1 divided by 2? Now we get -1/2. So -1/2 right here, they're saying, and this is where you can look at going, yeah, that looks about halfway. Actually, it may not be there. It may be a little bit further down, is where you might be going, oh, I don't think it's right there. I think it's a little bit further down. That's all right. It's one of those that we have, the question is not what's exactly, where is it? What is the slope? Well, we know it's negative, which means we got to come down here somewhere. The question is, how far do we have to come down? This looks pretty steep. So now this is where it comes down to, you may think of something, I may think something else. I see this as being fairly steep. If this slope was 1, then it would be going from here to here to here. but it's not doing that. Now, if the slope was 2, it would be going from here to here, which is closer. So this slope is probably a little bit more than 2. So let's bring him all the way down here. And because these slopes are quite steep, we can graph our graph here, our derivative, that way. And there's where you have. But you look for your slopes at 0 and where it looks like they're turning. Where does it go from? You know, this is going to be the harder one. Concave up to concave down. Actually, this is concave down. When does it change from concave down to concave up? This is concave down. When did it go from concave down and switch to go concave up? That's the question. Because then that's where you're going to have your vertex here of this thing. Comes down and comes back up. Now, yours may be a little bit better looking than mine. You may be going totally off on yours. Hard telling. But that's what we have to look at. Okay, so we had one where they go, here was f prime, or they actually graphed f prime, the other one, graphed f prime. So let's look at a couple more. So this one here, they say sketch the graph of a function f that has the following properties. 1, f is 0 equals 0. The graph f prime, the derivative of f, is shown. So this is the derivative. And f is continuous for all values of x. That just means that at 1, the point continues. Even though the derivative have open circles there, when you graph the function, it's going to have points. So what we do know is we have a point here at 0, 0. Always grab those things like that. Point 0, 0. This is the derivative. So I have this point at 0, 0. But at 0, I have a slope of -1. So from here, I can graph the point of -1. Go up 1 over 1. And I can go down 1 over 1. You guys know how slope works. And remember, at x equals 1, my slope is going to change. It's going to go back up to 2. So this is x is less than 1, and this is when x is greater than 1. Less than 1, my slope is -1. And up here, my slope is +2. So I have this guy, and I can draw a nice little line. Okay, you guys get to pretend I did a really straight line there. And now from this point, since I'm at 1 now, I use this slope. Up 2 over 1. Up 2 over 1. And you should see a slight change in the slope. And then we have, these are the easier ones to follow. To actually get a graph and try and graph the derivative off of it, or even the function off of it, is really difficult. But when they actually give you information that you can use, it makes it a little bit nicer to do. Okay, so this one here, we can talk more about in class kind of thing. But keep in mind, they gave you a point, and that's where you start. And you know that your slope values change at 1. So I couldn't just keep doing my slope this way because my slope value changed at 1. Let's try another one. Okay, this one I didn't even make a thing for. Okay, sketch the graph of a continuous function of f with f of 0 equaling 1, important information. And then they gave you f prime. Remember, these are slopes. F prime of x equals m, and just in case you don't remember what m is, slope. So since I don't have a grid here, let me make one. Make one through here, and let me clear that out so I can get rid of this guy. I don't know why he showed up. Okay. And all I know is that I've got a few little points in there. And from this point on, I'm going to sketch. It's a sketch, which means sketch just, that's what it means. So let's go 1, 2, 3. I'm going to go 3 out. If I need to do more than that, I'll do more. I'm going to go 3 out in every direction. Now keep in mind that this is slope, so this is x and y. So I know I have a point at 0, 1, 0, 1. Here he is. Make him nice and dark so you can see him. But my border points are 2. And since 0 is less than 2, this is where I'm going to start. But I need to get over to 2. So as I move over to 2, my slope is 2. So up 2 over 1. Yep, I'll need to put some more in there. Up 2 over 1. So I have a point here. And then I can draw this one. That's not a very good one because it shouldn't have gone to that point. There you go. Now that I've gotten from 0, 1, I've gotten to my border point of 2. Now I can use my slope of 1. So down 1 over 1. Down 1 over 1, and so forth. And again, you should be seeing the different things going on. Now, if nothing else in this chapter, the biggest thing is to keep in mind that the derivative is a slope. And if I give you an equation, not an equation, if I give you the graph of the function, you can give me the derivative. Or if I give you the derivative of the function, you can give me the graph. Going backwards, that I do need to point out, like this one, I call that going backwards. Here's the derivative. I want you to go back to the function. They have to give you a starting point. They have to give you a starting point somewhere. Otherwise, this graph could be anywhere on. It can be up, it can be down. I can't move it sideways, but I can move it up and down. And so if they didn't tell me f of 0 equals 1, then I could have gone, well, I'm going to make f of 0 be 5, and then I could have done it from there. So they do have to give you a starting point going that direction. Okay, I believe this is it for the chapter. It is for this section. So we'll work some more on some of the more difficult problems in class and get you guys going on those. Good luck.